Alright guys, before you willy-nilly start adding wires everywhere to the circuit, you have to know how a breadboard works. It's super simple, just follow along. This right here is a breadboard, and luckily enough, the software that I'm using, called Tinkercad, tells you exactly what connections is made underneath the breadboard. So as you can see, this whole top wire is highlighted, meaning it's all connected. So if you add a wire to itself, that essentially does nothing because it's all connected. Same thing with the positive on both sides. Now for this middle part, you would notice that it's not connected horizontally, but vertically in these small segments, which means if you want to connect 8 and 11, you just have to draw a wire from 8 to 11. Now you have this connected with this. Alright guys, now that we know how a breadboard is wired up, we'll just run through a quick and simple LED circuit. Okay? We will be using pin 13 on this Arduino. So let's drag pin 13 and why not? Let's connect it to 13 on the breadboard. So that means from pin 13, any one of these spots is all connect to pin 13. It's all in series. Next, we will be using a resistor. It is always good practice to put a resistor right before your LEDs because most LEDs can't take much amperage. So we'll be using a 300 ohm resistor. That's more than enough. We will connect one end to the side where is connected to pin 13. Then we'll get our LED, connect the anode side to the other side of the resistor. So as you can see, everything in row 9 is connected. So therefore, this terminal 1 of this resistor is connected to the anode here. And then on row 8, the cathode of the LED is connected there. And we'll just connect row 8 to ground, which will complete the circuit. So the circuit will flow from pin 13 to row 13, and then to terminal 2 of the resistor, come out the other side of the resistor, terminal 1, go through the anode of the LED, come out through the cathode of the LED, and go straight to ground. Now for code. It's going to be super simple. Since we're using pin 13, we have to set pin 13 as an output. So we're going to type pin mode 13 as output. Once we set as output, we want to set a high value to it, which is just basically sending 5 volts through the system. So it's going to be digital write pin 13 high. This is all we need for right now, just to set pin 13 as an output, and then we just want to write a digital signal of high. So if we run the simulation, look at that. The LED lights up. Okay, so now that we learned how to use the digital pin as an output, let's learn how to use it as an input. we're going to be using a push button for that. Just going to plop it down here. And what a push button essentially does is when you push the button, it'll connect side 1, which is this side, to side 2. So right now, there's no connection right now. But as soon as you press the button, there's going to be a connection horizontal. Okay? So let's just quickly wire this up. This is how you would wire as an input. First, you would need to use the 5 volts provided by the Arduino to go through this side. So now everything here is connected to 5 volts. All of 13 on both sides, since terminal 1A is connected to terminal 1B. So now how do we connect it to this other side? You push the button. So as of right now, since it's not being pushed, it's cut off. So what we'll do is connect 15 and we'll use pin 13 again. So the circuit now goes from 5 volts, which is the red. It'll go through row 13 and wait for someone to push the button so then it can cross over to row 15. And in this case, row 15 is connected to pin 13. Okay, so now let's see how would it look like in code. So as before, we would set the pin 13 as an input this time. So pin mode 13 as input. And how would you read it? It's very similar to digital.write. In this case, it's digital.read. Digital read. And you would just simply put pin 13. So if we run it and start the simulation, nothing happens. Until we push the button. Does something happen? Push. As you can see, the little LED on the Arduino starts turning on and off. But how will that help us, in code? Like, it's great that the LED turns on and off, but, we might want to see, like, maybe take in a value. And once we see that value, we want it to do something else, probably. But how would we know that? Well, there's a great thing that Arduino provides, a little monitor. It's called the serial monitor. And a way to access that is first in your setup, you would write serial.begin. And in serial.begin, just starts up the monitor, which is down right here. And now to write to the monitor, we do serial.println, and we could just copy this and paste it there. So it'll print what it reads in pin 13. So if you run it, you see there's a bunch of zeros down here. That means that it's not reading any voltage. So as soon as you click the button, you start seeing ones. Right now I'm holding my mouse. So I'm holding the button down. As soon as I let go, you'll see zeros again. Now I'm just clicking on and off. This can be super useful for something like a limit switch, which is just a little button. Let's say when it gets clicked, let's say you want to read when it gets clicked. Now you have a way. If digital read 13 reads a 1, that means something's pushing down on that button. Okay, now we're going to learn about analog input. And a key difference of analog input from digital input output is that an analog input takes a range of voltages going from 0 to 5, while a digital only sticks with the binary 0 and 1, low, high, in both input and output. So we're going to make a quick little circuit using a potentiometer. What a potentiometer is, it's basically a variable resistor. So instead of having a set resistance from a resistor, the more you spin it, the higher resistance or low resistance it goes. It changes its resistance basically. And we'll use analog input to get the value, at which resistance it is. Okay, so the way we wire up a potentiometer is terminal 1 being connected to 5 volts because we need power. Terminal 2 connecting to ground to complete the circuit. And to get the value of it, the potentiometer has this pin in the middle called the wiper, and we'll just drag that and connect it to this row, which already conveniently has a wire going down to analog in pin A0. Okay, now for code. I already have serial.begin in the setup and serial.println in the loop. Now for analog in, you don't really need to set if it's an input or an output because it's input, hence the name analog in. So we'll just type analog read, same thing as digital read, and then the pin A0. So what this code should do is print to the serial monitor whatever value it's getting from pin 0. So if we run it, you can see we're getting a value of 1023. That's just basically the high value. The more we turn it, you see it keeps getting lower and lower. This is what I mean by it taking a range instead of just high or low, or 1 or 0. The numerical value just goes from 0 to 1023. Now that we learned digital input, analog input, we can use that knowledge to test any sensor out there, as long as they're either digital or analog sensors.